Hello, Discrete Math students. Okay, this is my second Mathematica video for you guys. What I want to demonstrate is the bubble sort algorithm in Mathematica. This is something we're going to look at in Chapter 3. Okay, this is something that we're going to look at in Chapter 3, so this is not material that has been assigned to you yet, but it will be assigned probably sometime next week or maybe even over the weekend. Excuse me. Okay, so first of all, this is Mathematica, and hopefully you have it downloaded and installed on your computer. I think I went through this before during the first video, but we can go through this again. You can edit your style sheet. Okay, let me do that again. Okay, for people who are following me more slowly, format, edit, style sheet. Okay, and then input, output. Okay, now I'm on a Mac, and if you're on a Mac, you can just do Command B, and that will cause your selected style type to be changed to bold. Okay, Command B, I'll do it one more time. Now it's not bold. Now the output is bold. You get the idea. Okay, pretty simple. So let's see, format, show fonts. 13 is just too small. Let's do 18. 18 might be a little too big, but that's okay. That way, for sure, you guys can really see it. I like Arial. Use whatever font pleases you. And I'm going to select Midnight Blue. I like dark blue. Let's do the same thing here for input. We'll choose 18, and we'll choose Arial, and then this is called Midnight. It's a very dark blue, basically. Okay, that looks pretty good. And you know what? I'm going to add a green background to my output, so just to make it look, more attractive. Okay. So let's see, light green. Okay, so I think that's going to look very attractive. Okay. Okay. So in this demonstration, we're going to learn a little bit about recursion. We're going to learn about sorting. Okay. So let me start with a title. Writing assistant and title cell. Bubble sort algorithm in Mathematica. Okay, terrific. And then I'm going to click right below it. So this is going to be the title of my Mathematica notebook, Bubble Sort Algorithm in Mathematica. Now, Mathematica has a built-in sort function. Okay, so for example, let's say I have a list. My list is equal to range 10, 0, and steps of -1, Shift Enter. I could use sort my list, and that's the result. Now, when people talk about sorting a list, usually what they mean is sorting from the smallest to the biggest number. Okay? Usually when people talk about a sorted list, they don't talk about this type of list that is sorted in decreasing order. They usually mean a list that is sorted in increasing order. Okay? Now, of course, this was not saved. My list is still not sorted. If I want to save the result, this is what I have to do. My list is equal to sort my list. Yes? Okay, so now I actually saved the result of the function. Okay, sort is a built-in function. But we're not going to use the built-in function. We're going to define our own function. We're going to define our own function, and this is going to take a little while, and you have to follow me very closely, okay? Of course, you can always pause and rewind the video if there's something that you missed, but you have to follow this very closely. This is not going to be a 2 hour or 1 hour video because uploading that to YouTube would take a ridiculously long amount of time. I'd like to make this video, no more than 30 minutes in duration, okay? So you're going to have to fill in some of the blanks for yourself. I can't hold your hand through every single step, but I'll do my best to explain what I'm doing as I'm doing it. Okay, so first of all, with bubble sort, what's actually happening in bubble sort is adjacent values are being compared. So the 10 and the 9 are being compared, and then the 9 and the 8 are compared, and then the 8 and the 7 are compared. So this is the way the algorithm is going to work. And if you implement it, you're going to see that with each pass or with each execution of the bubble sort algorithm, the most minimum value of the list is actually going to bubble all the way to the right end, or some people call it the top of the list. Okay, but the problem is, what about all the other values? So let's go through this, as slowly as possible. I don't want to go through this extremely slowly because then I'll be making this video until midnight, right? But let's go through it step by step. So I'm going to start with bubble. I'll call it bubble, which is like a helper function or an auxiliary function that will support the main function. Okay. And I know that my argument to the function has to be a list. So I have x. This is going to be, the first element of my list. Well, first of all, hold on 1 second. Before we even do that, hold on 1 second. What happens if I have an empty list? How do you sort an empty list? Well, the answer is easy. The answer is simply, the empty list. Because the empty list is already sorted, so there's not much going on there. Okay, here's a comment. The empty list is already sorted. Terrific. Good. I'm usually a good typist. Okay, Shift Enter. Terrific. Now, what if I have one element in my list? What if I have only one element in the list? Well, that list is also sorted, okay? So then I have bubble. Okay, x underscore just represents a number, okay? And that the answer to that is simply going to be the list itself with that one number in it, okay? So this is called a singleton list. A singleton list is already sorted. So there's not much to do. Okay. Now it gets more complicated if there's two or more numbers in my list. So then there's going to be a little bit more work to do. Okay. Bubble. Okay. And then what I'm going to do is I'm going to call this x's with 2 underscores. So the 2 underscores means that x is followed by one or more values. Actually, you know what? Hold on 1 second. Let me do this. Okay, my family's having dinner in the kitchen right now, which is a little bit of a distraction, but okay, the joys of working from home, right? Okay, so now we're dealing with the list that has 2 numbers in it. Y's with 3 underscores. So let me highlight this. This is going to represent 0 or more values. So this pattern right over here, what does this pattern represent? Okay, so x represents a number, x underscore represents a number, y underscore represents a number. Y's underscore underscore underscore, or y's triple underscore, represents 0 or more numbers. 0 or more numbers. This particular pattern will match 0 or more numbers, which means that this entire pattern right here represents a list having 2 or possibly more values, 2 or possibly more numbers. Okay, so let's try this out. Then we have, let's do a condition. We need a condition here. What if x is less than or equal to y? Then we're going to have prepend bubble y's, and then prepend means that I'm putting x in the front, so I'm not changing the list. I'm not changing the list at all. The list, I mean, I'm not changing the list at all, okay? So prepend simply means take x and put that in front of the rest of the list, and then I'm going to, continue bubbling through the rest of my list. So there's not a whole lot going on over there, so Shift Enter. Now the next situation to consider is x underscore y underscore y's. X is now greater than y. Now what are we going to do in that case? In that case, we have prepend bubble. Now remember, y is the smaller of the two numbers. Y is less than x. So I'm going to have x, y's, and then y is prepended to that. Okay, now let's see if this works. Hopefully it'll work. Okay, so bubble, empty list, terrific. Bubble 1, terrific. Bubble 2, 1 should give me back 1, 2, terrific. Bubble 1, 2 should just return 1, 2 because 1, 2 is already sorted. Okay, so this works just fine. These definitions work terrifically. Now, you're going to notice something interesting. Like in a language like Java, for example, you don't see multiple clauses or multiple definitions of a method. In functional programming languages, especially in languages like Mathematica and Haskell, it is perfectly acceptable to have multiple function clauses. This is also true, by the way, in the programming language Erlang, which is a language I'm actually learning right now. So in languages like Mathematica, Erlang, Haskell, you are allowed to have multiple definitions for one function. You are allowed to have multiple function clauses. And the nice thing about this is that it helps you avoid these ridiculously long and deeply nested if-then-else conditional statements. Okay, because if I was doing this using an if-then-else statement, my God, I mean, I would have to have one if case for this situation or this case, another if condition for this case, and then for this case, and then for this case. I would end up with 4 if statements. I mean, or 3 if statements and then an else. I mean, and those are difficult to read. I mean, they're difficult to read. Code like that is difficult to maintain if you go back to it at some point in the future. Because then you're looking at it and you're wondering, what the hell is this, right? What did I do? Okay, now the problem with my function is that it's limited as it is right now. I have bubble, okay, let's try this. 3, 2, 1, 0. Okay, So that's not really working, right? I mean, the 3 did bubble up to the top, which is what I predicted, but the 210, right? The 210, that hasn't been sorted yet, correct? That hasn't been sorted yet. Okay. So what about this? Bubble 2103. It looks better. So now we see that it's slowly becoming sorted. Bubble, oops, bubble 1023. Okay, terrific. So now we see that after, let's see, 1, 2, 3, after 3 iterations, or 3 repetitions of bubble, my list is now sorted from the smallest number to the largest number. Okay, that actually looks pretty good, right? So where does the number 3 come from? Well, look at the length of the list. The list contains 4 elements. So I had to repeat the process 3 times. So it's the length of the list minus 1. If you're a little paranoid or extremely cautious and you really want to make sure the list is sorted, you could sort the list n times, where n is the length of the list. So then you are going to have to apply this function n times, where n is the length of the list. How do you apply a function n times? Okay, so this is where we need another function. We're going to use another function. And hold on just one moment. Okay. Okay, let's get back to the video. Okay, so how do we apply a function that many times? So I'm going to make up a function called apply, and I'm going to have a function. I'm going to have an x value, and n is a number. Okay, so if n is equal to 0, simply give me x. Otherwise, apply f of x, n minus 1. Again, this is a recursive function. Why is it recursive? Because the function is actually calling itself. Apply is the name of my function, but notice that apply does call itself, right? Okay, so let's try this. Let's give this a shot. I want to apply the square root function, let's say 4 times. Apply the square root function. Okay, so I'm creating what's called an anonymous function. So I'm not using any letters, no ABC, no XYZ, but the format for that is going to be name the function, hash mark, and you have to end it with an ampersand. And let's say I want to take the square root of 3.0 and I want to apply the square root function 4 times. Okay? Let's see if that works. Square root, square root, square root, square root, 3.0. That looks good. I could also do this, 3.0, square root, square root, square root, square root, and I get the same answer. So notice the function works just fine. I applied the square root function a total of 4 times to the input value of 3.0. Now, you have to be careful. Remember that Mathematica is a computer algebra system, which means that Mathematica is able to handle symbolic evaluation very well. Most programming languages aren't able to do this. Actually, Python can do it, but for Python to do it, you need to install the third-party library called SymPy. You need SymPy in order to do that. SymPy is a library that allows Python to do a lot of computer algebra and symbolic evaluation, similar to Mathematica, but I still think Mathematica is better for that than Python. That's my personal opinion. Okay, so what if I do this? So apply the square root function, Okay, 3, 4 times. Okay, we're going to apply the square root function to the number 3 4 times, right? What am I going to get? 3 to the power 1/16. And if I want to change that into a number, I mean a floating point number, all I have to do is 1/16, okay? And then postfix capital N. This is called postfix notation because the function is applied after the argument. And then again, I see it's 1.07107, etc., etc., etc. Okay? So this is working very well. So now we have everything we need to implement the bubble sort algorithm. Let's try it. Okay, so bubble sort. I'm using camel case notation. Please do not do this. This will confuse Mathematica. This works in some programming languages, but this does not work in Mathematica because the underscore has a very special significance in the Mathematica language. So you cannot include that in the name of your functions. That's a very bad idea. So I'm going to use camel case where, you know, the first word begins with a lowercase letter and then the second word of the variable name is capitalized. So this is called camel case. And we're going to have a list. Okay? And we're going to have a module. I'm going to modularize my function. So length, or I could say number of iterations. It's kind of a long variable name, but it's useful for educational purposes, right? So that's going to be the length of my list minus 1. Okay. And then I'm going to have apply the bubble. 1 second. I did call it bubble, right? Yes. Apply the bubble function to my list, number of iterations. So that's going to be 1 less than the length of the list, right? And close everything. Close my function definition, close the module. Okay, terrific. Shift enter. It looks good. Now let's see. I'm going to create some random integers, okay? So unsorted list is equal to random integer, okay? Random integers from 0 to 10, and let's take 30 of them. I want 30 integers, 30 random integers between 0 and 10, okay? Here we go. And sorted list is equal to bubble sort unsorted list, and it looks good. 0, 0, 0, 0, 0, 0, 1, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 5, 6, 6, 7, 7, 7, 9, 9, 10, 10. Okay, so it worked beautifully, right? So we can see, we learned several things from this video, okay? Number one, if you use the bubble algorithm only once, you will get the maximum value, the maximum number of the list will get bubbled all the way to the right end or the top of the list, okay? However, what about the rest of the list? You still have to sort the rest of the list. In order to sort the entire list, you have to apply the bubble algorithm n times, where n is the length of the list minus 1. I mean, you could simply say length of the list. Instead of length of the list minus 1, you could use the length of the list. But then a lot of people would argue that the last iteration of the bubble algorithm is really not necessary. It's wasteful, and you know, you're using up valuable computing time. So it's really not necessary. It's overkill. So really, it's the length of the list minus 1. Okay? Now, this is a very functional way of implementing the bubble sort algorithm. This is a very functional approach. This is not the typical imperative or object-oriented approach that you learn in, a typical C++ or Java programming course. This is a functional approach. Okay, this is a functional approach to the implementation of the bubble sort algorithm. I hope this was helpful to you, and I should probably email this to the class. Perhaps that will be of use to you. And I think that's going to be it for now, okay? All right, guys, so maybe I will do something similar in Haskell tomorrow. Tomorrow's Thursday or maybe Friday, and I will send that to you. Again, I realize there are a few people in the class who don't have a lot of programming experience. I think most of you are computer science or computer engineering majors or minors. So most of you have a lot of programming experience. I realize a few of you don't. So I'm not going to hold you responsible for learning Haskell. Haskell is pretty intimidating for beginners. However, I am going to hold every person in the class responsible for Mathematica. You have to learn the basics of Mathematica if you want to succeed in this course. That's not an option. That is absolutely not an option. And in fact, that is so stated in the syllabus for this course. So that is absolutely not an option, okay? I don't want to hear from anybody, oh, I don't like Mathematica, I don't know how to program, I'm sorry, I can't use the software. That's just not going to work, okay? You are going to have to learn the basics of Mathematica if you want to succeed in this course. Not using Mathematica is really not an option for you. You must use Mathematica. As for Haskell, excuse me, as for Haskell, that is optional. That's completely optional. There will be 1 or 2 extra credit assignments at the end of the course, and those extra credit assignments will be based on Haskell. If you don't want to worry, if you're not going to do the extra credit assignments, excuse me, if you're not going to do the extra credit assignments, then there's no point to worrying about Haskell. Just don't worry about it. The Haskell stuff is really there for people who want the extra credit, and the extra credit is not absolutely necessary. You can get an A in the course even if you don't do any extra credit at all. But if there is extra credit in the course, I guarantee that the extra credit will require Haskell and not Mathematica, okay? Okay, enough said. I think we're done with the video. Have a great day and goodbye. Bye for now.